Hi, today we're going to look at section 7.3, which has to do with complex fractions. Don't let the name scare you, it just means a fraction which itself has other fractions in it. So the classic type of a complex fraction is of the form a over b over c over d, and the first thing we'll do is we'll look at how to do a simple complex fraction like this, how to simplify one. So notice that when you look at a over b over c over d, you can write that as a division. So by definition, that means a over b divided by c over d, which then we know that we need to turn into a multiplication before we proceed. So we keep the a over b as is, turn the division into multiplication, and flip the second fraction. So like so, right? So if you notice, a times d over b times c. There's a nice shortcut which says when you have a over b over c over d, what you can do is you can just say that's equal to this far product AD over this near product B times C. So keeping that in mind will enable us to handle a complex fraction such as this one, say for example, just a simple example, 2/3 over 4/5 in a very simple manner, because we know that this is going to be this far product 2 times 5 divided by this near product, which is 3 times 4. So now if you notice, there's some cross canceling that's possible. You always remember the golden rule, always simplify before you multiply, because that's going to make your numbers a lot smaller and your work much easier. So here, if we cross cancel, we get 1 up there, 2 down here. Now we go ahead and multiply across, so we just end up with 5 over 6. So that's the simplest kind of complex fraction which we can encounter, and that's how we can handle it. So let's look at a few more examples with this simple variety. This time we can bring in some variables. For example, let's say we have, of course the instruction for all of these is to simplify. So let's say we have 2x over 5 over 3x over 10. We can use the same useful shortcut with something like this. Remember, this is going to be the far product, which is 2x times 10 over the near product, which is 5 times 3x. Okay? Now we try to see if there is any cross canceling that we can do before we can proceed. And we notice here that 5 and 10 have a common factor of 5, which we can divide off, and we end up with a 1 down here and a 2 up there. Now we notice there's one other cancellation, and that is the x's. We can cancel those, and that's it. There's no more legal cancellation that's possible, so we go ahead and write the result as 4 2 times 2 over 1 times 3, which is 3. And that will be our final answer for that. Okay, so go ahead and pause your video after I write the next problem down. Try it first before you come back to try to see what the answer is. Okay, so at this point, go ahead and hit pause. Try to see what you end up with for that, and then come back when you're finished. Okay, now that you're back, I hope you tried it on your own. Notice, as long as you have one fraction over one fraction, you can apply the A over B over C over D rule, which was, if you remember, A over B over C over D equals what? Far product over near product. So AD over BC. So we can apply it here. So we're going to end up with 3y squared times 16 on the top, and with 8 times 9y squared downstairs. Okay. So notice that at this point we can go ahead and cancel some items such as the 3 and the 9. They leave us 1 and 3. The 8 and 16 leave us 1 and 2. And the y squares cancel completely, leaving just ones, right? So basically all that's left of this complex fraction is 1 times 1 times 2, which is 2 over 1 times 3 times 1, which is 3. And that's what we have there. Okay. Try this one now. Go ahead and pause the video and try this. Okay, so notice we do have just one fraction. Look at how many fraction lines we have over just one fraction, so we can apply our shortcut. So it's going to be this far product over the near product. Now I can put d plus 5 times 60, or I could put 60 times d plus 5. Makes no difference because multiplication is commutative. So I'll go ahead and write the monomial first. It makes it a little bit easier. So you get 6d times d plus 5 over the inner product, or the near product, is 3d times d minus 1. So now, as usual, we'll go ahead and try to cross cancel any possible items that we can. And we notice that 6 and 3 have a common factor of 3, which leave us 2 on the top, 1 on the bottom. These d's cancel completely, and so we're just left with 2 times d plus 5 on the top, and we're left with d minus 1 on the bottom. Now, we notice there is no more legal cross-canceling possible because that's a term, we can't cancel the d's. So that's basically the final answer. You can write the answer like this, or you can go ahead and multiply that 2 in, now that you're sure there's no more canceling possible, to end up with 2d plus 10 over d minus 1. Either one of those two forms is acceptable. Okay, so the simplest type, as we discussed, only has one fraction on the top, and one fraction on the bottom. Next, we want to look at a type where you may end up having more than one term or one fraction on the top in the numerator part or in the denominator part. So let's look at how we need to handle something like that. So let's say we have something like 2 minus 5 over x over 3 plus 1 over x. Okay, so to handle something like this, you have two options. This one you can think of as the classic method, and this time you can think of and this method you can think of as the LCD method. Okay, so for the classic method, you notice that that's basically like 2 over 1 minus 5 over x over 3 over 1 plus 1 over x. Now, notice that we put the ones here to highlight the fact that you have more than one fraction, so you shouldn't do the outer product over the inner product or the far over near. And also, notice the fact that it allows us this way to combine these two terms as if they're both fractions. So, as usual, we need to find an LCD. Here the LCD is very simple. It's just x. So, and notice that the denominator, which is 1, you're going to have to multiply it by x to turn it into the same as the common denominator. And the top needs an x factor as well. This denominator is already x. We don't need to do anything with that one. So now notice both denominators are x, so we've turned them into like fractions, so we can go ahead and just combine the numerators, which are 2x minus 5. On the bottom, we have also a common denominator of x. Notice that we can multiply 1 by x to turn it into the common denominator, and so we need to do the same on the top. So now both denominators are x, and we can go ahead and combine the numerators. So we get 3x plus 1. Okay, now if you notice, we have just one fraction over one fraction. So we can do the a over b over c over d trick, which is going to be the outer product AD over the inner product, which is BC. So doing that with this complex fraction, we're going to get this product over this product. So the longer product, the farther product goes on the top. So x, I'll write the monomial first, x times 2x minus 5 over the inner product, which is going to be x times 3x plus 1. Okay? So now I notice that these are, you have 4 factors. This is one factor, that binomial is one factor, this is one factor, and that binomial is one factor. So we only see factors. Remember, it's okay to cross-cancel factors. So we can go ahead and cross-cancel these x's, and we end up with 2x minus 5 over 3x plus 1 as our final answer. So that's one, this is the classic method, okay? Now the LCD method is actually, which I'm going to show up here, is actually quite an amazing method. You're going to find out soon that I'm a big fan of the LCD method. So let's write down the problem again. 2 minus 5 over x over, remember this is we're finished with the problem. We're doing it now using another method, which we call the LCD method. So 2 minus 5 over x over 3 plus 1 over x. The same problem, okay? So with this method, what you do is you look at all the fractions in the problem. Remember, you can write these as fractions as well if you like that, right? So the denominators are 1x, 1x, right? So what is the LCD for all of those fractions? Notice it's just going to be x. So what we do this time is we use the fact that when you have a fraction, whether it's simple or complex, it's always okay to multiply the top and the bottom, the numerator and the denominator of that fraction with the same number. So this time, what we're going to do is we're going to multiply the numerator, which is this, and the denominator, which is this expression, by the LCD, which was x. So we have to do this like this. The reason we can do that, because x over x is 1, so we're just multiplying by 1. And notice that we have to distribute now because there's more than one term. So basically, I'm going to get x times 2 over 1 minus 5 over x times that x. So I'm just going to write that x over here. And the same here, we have to distribute. So it's going to be x times 3 over 1 and then x times 1 over x, right? So now we go through and we see if we can simplify those. And we notice here that here we just end up with 2x minus, notice here the x's will cancel out. So you just get minus 5. And here we end up with 3x and then plus, notice the x's cancel out again, leaving us 1. So I think you can see how much quicker and more efficient the LCD method is. We basically got to our final answer here, which we had to go through all this work for immediately, okay, like in one step. So it's really, really efficient and a powerful method that we'll be utilizing more and more. But this method is also good. It's classic. It keeps your fractional skills very strong. So each has its own strengths. So we'll look at a couple of more examples. And we'll utilize both methods in these examples that we will do. As you can see, these I bought this fancy glass board, but unfortunately it's not very eraser friendly, so I think I'm gonna have to just order like one of the ones we have in the classroom, because they seem to work a lot better with erasers. So anyway, all right, so let's try this one. We have 3k plus 4 over k minus 2 over k minus 7 over k. So this problem is in the PDF lesson, which I've included on Canvas for you. So don't stress too much about necessarily writing the problem down, just focus on understanding. Okay, so on this side, we'll do the classic method. And on this side, we'll do the LCD method. Okay, so for the classic method, notice that we're just going to go ahead and throw a 1 under those two fractions to turn these both into fractions. And we will go ahead and find the LCD for the top. Notice you have two terms, two fractions, and the LCD is just going to be k minus 2. So we have to turn the 1 into k minus 2. That's going to require us multiplying by k minus 2. So that's what we'll do. use a pen that might be easier to see for you. So we multiply by k minus 2. And don't forget, whatever we do down here, we have to do on the top as well. So we multiply by k minus 2. And this one is already k minus 2, which is the LCD. We don't need to do anything with that one. So we end up with 3k times k minus 2, and then plus 4. And down here, we have a common factor of, a common denominator of k. And in order to turn this 1 into k, notice we need to multiply by k. So we have to do the same downstairs. Okay? So this denominator is already k. We don't need to do anything with that one. So we're ready to go ahead and combine the numerators. So the new numerator on this one is k squared, k times k, minus 7. Okay? Now, we're going to go ahead and simplify this expression. So we're going to end up with what? 3k squared minus 6k plus 4 over k minus 2. Let me write that a little further up. So 3k squared minus 6k plus 4 over k minus 2, and this one is already simple. K squared minus 7 over k. Okay, so now we notice that we now have one fraction over one fraction, so we can go ahead and do the outer product over inner product trick. We end up with, let me write the k first, k times all that and down here we end up with k minus 2 times k squared minus 7. So if I go ahead and distribute the k here, I end up with 3k cubed minus 6k squared plus 4k. And if I go ahead and multiply that fraction, multiplication, remember we can use a box method for that. So we have k minus 2 times k squared minus 7. We go ahead and multiply that out. We end up with k cubed here minus 7k minus 2k squared and then plus 14. So if you notice, there are no like terms with the terms that we get for the product, so we're just gonna write them all in descending order. So we end up with k cubed minus 9k squared and plus 14. I'm sorry. I did it, didn't I? I combined those. K cubed minus 2k squared minus 7k plus 14. Remember, there are no like terms, so I did a quick incorrect combination there, as you notice. So it's just going to be k cubed minus 2k squared minus 7k plus 14. And we are basically finished with that. Now, sometimes if we just have a trinomial, we'll try to factor, but in this case, it's pretty safe to say that we are in lowest terms. Now, if we use the other method, so we have 3k over 1 plus 4 over k minus 2 over k over 1 minus 7 over k. So if we use the LCD method, we need to look at all the denominators here, and we need to find the LCD. Notice the denominators are 1, k minus 2, a 1, and a k. So the LCD is simple. If you notice, the LCD for the entire complex fraction is k times k minus 2. So we're going to go ahead and take that k times k minus 2, and we're going to multiply it on the top and distribute. So that means basically you're going to see a k times k minus 2 next to each of these two terms, and we're going to write it down here and distribute. So we're going to end up with a k times k minus 2 next to each of these 1, 2, 3, 4 terms, okay? And that's because of distribution. Okay, so now we're going to go through and we're going to try to cross cancel if possible and write down what's left. So notice that on the top here there is no cross canceling, but here we can cross cancel the k minus 2's, right? Here there is no cross canceling, but here we can cross cancel the k's, right? So notice we end up with 3k squared times k minus 2. Got to do this very, very carefully, plus 4k. Now down here you're going to have k times k, which is k squared, times k minus 2 minus 7 times k minus 2. So there may be the temptation of canceling, but you know that we can't do that because there are terms, and we never cross cancel terms or any parts of terms. The only time we can cross cancel is when all we see on the top or on the bottom are factors, okay? So notice that we have to just go ahead and distribute this out. So we get 3k cubed minus 6k squared plus 4k over k cubed minus 2k squared minus 7k and then plus 14. And not surprisingly, it's exactly the same answer as we got using the other method, because after all, it's a different method. You shouldn't get a different answer. So we end up with the same answer in both situations, okay? There's that. So let's go ahead and try some where some simplification may be possible. And this is when your factoring techniques are going to have to be sharp, because we're going to be doing some factoring in order to do some cross canceling. I can't wait till my new board arrives, which is the one like the one we have in the classroom. Okay, so let's go ahead and take a look at this example. Three over x minus 1 over 4 over x squared minus 1. We'll do classic as well as the LCD method. Okay, I would like you to pause the video and try to get the answer on your own first. Okay, I hope you're back after your attempt. Notice that for the classic method, we do have just one fraction over one fraction, right? So we can use our A over B over C over D shortcut. Remember, A over B over C over D equals what? Outer product AD over inner product BC. So the outer product here is going to be 3 times x squared minus 1. And the inner product here is going to be 4 times x minus 1, right? Okay, so this is when your factoring needs to be sharp. Notice that here we have a difference of squares, right? So we can factor that, as you know, as using this formula, right? F squared minus L squared equals F plus L times F minus L. In that situation, your F is X and your L is 1. So applying this formula with this F and this L, we end up with what? X plus 1 times X minus 1 over 4 times X minus 1. All right, so we have nothing but factors on top, nothing but factors on the bottom. Therefore, we can cross cancel. So we're going to cross cancel the X minus 1s legally, and we're only going to end up with 3 times X plus 1 on the top, and we're going to end up with 4 on the bottom. You can write that, leave the answer like that, or you can multiply it through. Most instructors, and even my math lab, they prefer you just leave it like that in factored form, because that shows that no more factorization was possible. Okay, so now we're going to try the LCD method. 3 over x minus 1 over 4 over x squared minus 1. So go ahead and pause the video and see if you can do the LCD method on your own first, and then come back. Remember, you just have to try it. You don't have to get it right, but it's important that you get rid of the fear of mathematics, and that can only happen if you just try it. Okay, don't be afraid. You're not going to break anything, so just try it. And then when you're finished, hit play again. Okay, so remember, the LCD method is different. For the LCD method, you look at all the fractions involved, right? And then see if you can come up with the LCD. But before we can see what the LCD is here, we need to factor this denominator. Notice that's going to be 4 over, as we just showed over there, x plus 1 times x minus 1. When denominators are both in factored form, it becomes a lot easier to find the LCD. And notice the LCD here is simple. It's going to be, you remember, you multiply the highest power of all factors. So basically, it's going to be x minus 1 times x plus 1. Let's keep record of it here. X plus 1 times x minus 1. Now we're going to go ahead and do the far product. We're going to go ahead and multiply the LCD, which is x plus 1 times x minus 1. Once on the top, once on the bottom. So I can just write it like this. And once down here. Remember, this is okay because we're multiplying the top and the bottom by exactly the same thing. That's how the LCD method works. So now if you notice, here we can cancel out the x minus 1s. And here we can cancel out the x plus 1s. And as well as the what? The x minus 1s. So what's left? Exactly what was left before. 3 times x plus 1 over 4. So while this method is definitely slightly more efficient, some people prefer this it's more of a personal choice. It doesn't. They're both correct. They're both perfectly good methods. So either way should work fine. Let's go ahead and use our factoring skills again with a new problem. And this one will include a situation where you have more than one term to deal with and more than one fraction to deal with. So we'll have to consider that aspect of it as well. Okay, so let's look at this one. Classic method here, and the LCD method on this side. Okay, so let's look at 1 over m minus 3 over m. I'm sorry, 3 over n, and the whole thing over n squared minus 9 m squared over m n. All right, so if we're going to apply the classic method, you know that you'll need to combine those two fractions first before you can do the outer product over the inner product. So you know what to do. Go ahead and pause the video and give it a shot first before you come to look at the way I do it. Okay, welcome back. I do hope you tried it on your own first. That's how this is going to be effective, because remember, basically this is all about you trying to improve your own skills. All right, so right now we don't have one fraction over one fraction, so we can't do the outer product over the inner product trick. So what we're going to do is we're going to go ahead and combine those two fractions first using an LCD. The LCD is very simple. It's just going to be what? M n, right? So notice that if I want m to become mn, I need to multiply it by n. And I have to do exactly the same on the top. And if I want n to become mn, notice we need to multiply it by what? By m. So we do the same on the top. So now they're both denominators are the same. Now they're like fractions, and we just combine the numerators. So the new numerators are 1 times n, which is n, minus 3 times m, which is just 3m. Downstairs, we can just leave it as is for now, because that's already just one fraction. Okay, so now notice we have just one fraction over one fraction. So now we can go ahead and do the outer product over the inner product trick. So we end up with mn times n minus 3m. Doesn't matter whether you write mn times n minus 3m or n minus 3m times mn. Makes no difference. Multiplication is commutative. That means the order of multiplication does not matter. Downstairs we have mn times n squared minus 9m squared. Now, before we know we can cancel the m's and the n's, but before we just write this out as the final answer, we should see if there is any factoring that's possible. And if you notice, once again, we have a difference of squares. So we're going to be able to use the f squared minus l squared rule again, which is f plus l times f minus l. Notice that in this case, f is going to be what? F is going to be n, and l is going to be 3m. All right, I sure missed a bunch of you giving the answer, but such is life. We have to be safe right now. So this is as close as we're going to get to a normal lecture right now. All right, so notice that I'm going to write the numerator down, which is n minus 3m. Downstairs, we're going to go ahead and factor that using this rule with this f and this l. So we get what? We get n plus 3m times n minus 3m. So, yeah, these are two terms, but I'm not going to cancel one of the terms. I'm going to cancel the entire binomial factor here with this entire binomial factor. That's a perfectly legal cancellation. So I can cancel that entire binomial factor with that entire binomial factor, leaving me 1 and 1, right? So finally, we're ready to write the final answer, which is going to be 1 over n plus 3m. And that's all we can do to simplify this. So you see, that's the classic approach, and it works fine. Now let's take a look at the LCD method. I'm just rewriting the problem. 1 over m minus 3 over n over n squared minus 9m squared over mn. Again, these are exactly the same problem, so I'm not doing a different problem, we're just doing a different method. We were already finished. This is the answer, the simplified version of this. Now we're just going to do it using the other method. For that, if you recall, we need the LCD, right? And this is really the kind of problem that the LCD method shines, because it's really so much quicker. If you notice the denominators, you have 1 here m, we have 1 here n, and 1 here which is mn. So with those three denominators in mind, what's the total LCD? Meaning the LCD for the entire problem. And notice then that's just going to be simple. What is it? I can hear you say it. mn, right? So what we're going to do is we're going to go ahead and multiply mn on the top and on the bottom. And notice this is the top we're talking about for the main complex fraction. And this entire thing is what we mean by the denominator. So we're going to multiply mn by the top and distribute. So that means we're going to get mn multiplied once, twice. And down here, that's just one term. So we only multiply it once down here. So mn times mn and then once down here, because this is just one term. All right, now we go ahead and cross cancel as much as we can. Notice the m's cancel out. Notice the n's also cancel out, right? So here, both m and n cancel out, just leaving a 1, right? So notice that on the very top, we have n left from this term minus what's left here, 3m over, and down here, all that canceled out. So we just left with that, n squared minus 9m squared. So now we're going to go ahead and see if we can factor this in order to further simplify. And we did that over here. If you remember, difference of squares with this f and this l. So we've already done that factoring problem. So that's going to be n plus 3m times n minus 3m. Once again, we can cancel out the n minus 3m's. Don't forget, it leaves a 1. You know, when nothing else but 1 is left, it's a good idea to write it so you don't forget. One of the most common mistakes for a problem like this is that instead of students correctly answering 1 over n plus 3m, they just answer what? You know it. They just answer n plus 3m because they forget the one that's left on the top. Okay, so be very careful with that. All right, so that's yet another example of that type. Let's do one more example before we put this section to bed. Well, at least one. We might even do two. We'll see how the first one goes. And since we have become familiar with both methods, we can pretty much pick one method now. So each of you will have your favorite. So my favorite is the LCD method. So I'm going to do the next problem using only the LCD method. So I'll show you what we're going to do, and this time we're going to have some negative exponents that we're going to play with. So I'll write one up with negative exponents and I'll do it for you. I mean, you can pause the video, of course, and try it on your own, but if you're a little bit confused about negative exponents, I'll do this one with you, and then the next one that we're going to have one more that you're going to try to do on your own first before we do it together. Okay, so let's look at this one. So b to the power of negative 1c plus bc to the negative 1 over bc to the negative 1 minus b to the negative 1c. As you write this down, because remember, whenever you watch these lectures or whenever you go through the PowerPoint presentations that I've put into my Canvas, make sure that you have some paper and pencil and you're working alone. Because remember, math is not a spectator sport. You're not going to learn it if you're just watching. Not in a very significant way that's going to last and you'll be able to take it to your next class anyway. So make sure you're following along. So the first thing that we need to do is we need to go, you may look at this, for instance, and say, what's complex about that? That's just a regular numerator over a regular numerator. That's not complex, but when we rewrite it, you'll see that it is. Because notice b to the negative 1, you can move it downstairs and it turns into what? B. So this expression turns into this expression when you use the rule x to the negative n equals 1 over x to the n. Remember that rule? Like that. So we'll apply the same rule here. That becomes b over c. Downstairs, we get what? We get b over c. Remember, this one goes down, becomes c to the 1, which is just what? C. And then minus c over b. Okay, remember I told you I'm just going to do this using the LCD method, right? So if I'm going to use the LCD method, and I encourage you to do the classic method on your own for practice, okay? But so that we can keep this lecture at an uploadable size, let me just do it using the LCD method. Notice that the LCD here, here are the four denominators, B, C, C, B. So basically the LCD is very simple. What is it? B, C, right? So there's the LCD. And remember, we're going to multiply it on the top and distribute, and on the bottom and distribute. So you really should see the BC multiplied what? 1, 2, 3, 4 times by each term because of distribution. So you're going to get times BC times BC and then times BC, and of course that means B times C, okay? Like that. Now we just go through and we cross cancel as much as we can. So notice that the B's cancel out. Notice that the C's cancel out. And here in this one, the C's cancel out and the B's cancel out. down here. So what we're left with basically is BC plus B squared over B squared minus C squared. Okay, it would be tempting to go ahead and put that in as the final answer, but remember, our final answers always have to be in simplest possible form, which means we're going to try to do as much factoring as possible on the top, as much factoring as possible on the bottom, and then see if there's any cross canceling that's possible. So if you notice, in fact, there is some factoring that's possible on top. We can go ahead and factor out a what? We can factor out a B, which leaves us what? C plus B. You should act as if you're in class and go ahead and say it out loud. It'll help you out and it'll make this feel more like a class and us feel less isolated, isn't it? So go ahead and factor this one. As you know, that's a difference of squares with F being B and with L being C. So that's just going to be what? B plus C times B minus C. Notice that we already mentioned that multiplication is a commutative operation. That means the order of multiplication doesn't matter. Remember, there is one other operation where that holds as well, and that's what? Addition. So addition is commutative as well. That means C plus B is also the same as what? B plus C. So that means these two expressions are basically the same. So we can go ahead and cancel those. So final answer is B over B minus C. Right there. All right. I would like to do one more problem together before we call it the day. And that is, I want you to try this first on your own and then we'll look at it together. So x to the negative 2 minus y to the negative 2 over x to the negative 1 minus y to the negative 1. So go ahead and pause the video, please, and try this on your own first before you come back and hit play again. Okay, welcome back. Notice that we're going to write all four of those in positive exponent form before we proceed. So that becomes 1 over x squared. This one becomes, so minus 1 over y squared. Here we have 1 over x minus 1 over y. Now notice that we look for the LCD. These are the four denominators. Remember, multiply the highest powers of all factors. So basically the highest power of x we see is x squared. The highest power of y we see is y squared. So we're going to multiply the LCD, which if you notice is x squared, y squared on the top as well as the bottom. Okay, so we're going to end up with multiplying x squared, y squared by 1, 2, 3, 4 terms because of distribution, right? So times, let me do it on this side, times x squared, y squared, times x squared, y squared, times x squared, y squared, times x squared, y squared. So now we cross cancel as much as possible. We notice that we can cancel those. We can cancel those. Down here, the x and the x squared leave you just x. The y and y squared here cross cancel, they just leave you a y on top. So let's clean it up, see what's left. So on the top, we have just y squared minus x squared. On the bottom, we have xy squared, don't forget the x by itself, minus x squared y. Again, we never want to stop too early. We don't want to force any factoring, but if there's one available, we need to do it to make sure that further simplification is not possible. So notice that up here, we have a difference of squares. That's going to factor as y plus x times y minus x. Down here, we have a common factor of, say it, you said it, xy. And that's going to leave us what? Y minus x, right? What do you multiply x, y to get x squared y? You just need an x, right? What do you multiply this y to get xy squared? You just need a y. So that's why it works out like that. We're just factoring out a GCF from these two terms, right? Which is xy. So now we go ahead and we cross cancel what we can, and we end up with what? We end up with y plus x over xy. And of course, fight any temptation to cross cancel this or this, because these are two terms and we can't cancel when there are anything other than factors available. So that's that. Okay, I told you that was the last problem, but all right, maybe I lied. One more. I just want to do one with constants in it. Sometimes we get really comfortable with variables and we forget about constant situations. So let me do one of these with you with just numbers in it so that you don't lose track of those, okay? So try this one. This is definitely the last one, I promise. 2 to the negative 1 plus 3 to the negative 1 over 3 to the negative 1 minus 4 to the negative 1. Okay? Again, remember what you're going to do. You're going to take all those negative powers, turn them into positive ones first, and then proceed with your method of choice. You can do the classic method or you can do the LCD method. All right, so go ahead and pause the video and try this. You should be able to do this. And when you're finished, go ahead and hit play. We can compare our answers, okay? Okay, welcome back from the pause. Remember, we're going to write these as powers with positive exponents first. So using the same rule as before, x to the negative n equals 1 over x to the n. We're going to go ahead and write this as 1 over 2 plus 1 over 3 over, this becomes 1 over 3 plus 1 over 4. At this point, I told you, you can use the classic method or you can use the LCD method. I'm going to use my favorite, which is the LCD method. So I notice I have 2, 3, 3, and 4 for my denominators. So the highest power of 2 is the 4, and the highest power of 3 is just 3. So 4 times 3 is what? 12. So the LCD that we need is 12. Notice we have 1, 2, 3, 4 terms. So when we multiply 12 on the top and distribute, we get 2 12s over here and again down here. So we need to see 12 1, 2, 3, 4 times. So times 12, times 12, times 12, times 12. Remember, we're not using the LCD here to combine fractions, we're using it with a different talent for a different purpose, the purpose of clearing fractions. So the 12 is getting multiplied on the top, okay? And also on the top in the main denominator. All right, so we end up with, notice that we can cross cancel. 2 and 12 leave us 6, 3 and 12 leave us 4, 3 and 12 leave us 4, and 4 and 12 leave us 3. So let's carefully write down what's left. We have on the top, we have 6 plus 4 over 4. This was a minus, my apologies. Change that to a minus. We have a 4 minus 3. Nothing else has changed. It's just that I wrote plus instead of minus. So change that to a minus, and we should be good to go. So we end up with 10 over 1, which is just what? 10. And that should do it for today. So you have a nice day. You stay safe. And I will see you for the next lecture.